Students, welcome back to our YouTube channel. It is the second lesson of Newton's laws of motion, and we are going to look at questions involving Newton's laws of motion. So the first question reads, a car of mass 1500 kilograms traveling at a speed of 35 meters per second is brought to rest in 10 seconds. Calculate the average retardation of the car and the average force applied by the brakes. So the first thing you do as a student, when you see a question, try to analyze what the question is trying to tell you to do. So we have the mass of that car as 1500 kilograms, and it is moving at an initial speed of 35 meters per second, and brakes are applied. So we have a braking force, and this braking force is going to make this car come to rest in 10 seconds. And one of the keywords is rest. When an object is at rest, it means that its speed is 0 meters per second. So we take rest as the final speed, and 35 meters per second as the initial speed. So we are going to, the question requests us to calculate the average retardation. Retardation means deceleration. So we have decreasing speed from 35 meters per second to 0 meters per second. So we're going to find the retardation and the average force applied by the brakes. So we start with the first part of the question. We are going to find the solution of retardation. So retardation, as I said earlier, is the deceleration of that car. So, and it's given by, from linear motion, we know that acceleration is given by the final velocity minus initial velocity divided by time. And from the question, from our question, we have the initial velocity as 35 meters per second, and the final velocity as 0 meters per second, and the time is 10 seconds. So our retardation, so when I have a negative before the letter A, which means acceleration, so negative A means deceleration or retardation, and it will be given by the final velocity, which is 0. Remember, this car was brought to rest, minus the initial velocity, which is 35 meters per second from the question, divided by the time, which is 10 seconds. And substituting our values in this formula, we will get our acceleration. So we have the initial velocity to be 35 meters per second, and the final velocity to be 0 meters per second. And if we substitute these values in our formula, we get our deceleration to be negative 3.5 meters per second square. So when we have negative, it means that this car is decreasing its speed. So we are done with the first part of the question. Let us move to the second part of the question, and it requested us to find the braking force. So from Newton's second law, we know that force is given by ma. So m is the mass of the car, and the a is the acceleration. In this case, we'll be having a deceleration. So a is negative, which is negative 3.5 meters per second square. So if we substitute the values of m and a to this formula, we'll get our force to be 1500 kilograms. Remember, 1500 kilograms is the mass of the car. We multiply by deceleration, which is negative 3.5 meters per second square, and we get a negative 5250 newtons. So we also have a negative in the braking force, and this means that the force was acting in an opposite direction to the motion of the car. And from Newton's second law, we know that the rate of change of momentum is directly proportional to the force and takes the direction of force. So the direction of force is in the opposite direction to the direction of the car. Thank you.